All right, we are on to part 2 of our final study guide. All right, so we're going to start with perimeter. All right, so perimeter means around. So we're going to find the perimeter around the outside of these shapes. All right, these two shapes. So the perimeter is just, we're adding up all the different sides. All right, so let's find the side that we are missing. Okay, so we have 10, 5, 4 going up in that triangle. It's not necessary for finding the perimeter because that's on the inside. 5, we don't have this side, and then 6. All right, so with this side down here, that's the only side we need to figure out what it is. So it's a rectangle right here, so we can just say that the opposite side is going to be the same. All right, so we just add it up, all the sides. 5 plus 10 plus 6, 5, 10, 6 plus 10 plus 5. All right, we add all those up on our calculator and we should get 36 meters. All right, that's fairly easy for that one. Now we've got a half circle and a square. All right, so we can tell it's a square. So we're missing this side, which is also 6 meters, and this side, which is also 6 meters, because this side is 6 meters from here to here, the diameter of our half circle. All right, now for a half circle, we need to figure out the circumference of it. So we have that formula. All right, so we need to find the radius. The radius of our half circle is going to be half of 6, or 3. All right, so we get the outside. For our square, we're just going to have 6 plus 6 plus 6. We don't need to do the other side because that's on the inside of our shape. So we get perimeter is going to equal 6 plus 6 plus 6. That takes care of our square. Now let's do our half circle. All right, so we only need to do 1/2. All right, 2 pi times the radius, which is 3. All right, we don't have to add in that diameter this time because it's on the inside of our shape. All right, so we add all that up, we get 18 plus 1/2 times 2 is just 1, so we just get 3 pi. All right, so we get 18 plus 9.42. All right, and that's going to equal 27.42 meters. Make sure everyone can see that. There we go. All right, so that deals with the perimeter of those two shapes. All right, we're just finding the size around the outside of our shape. Now let's find the area. All right, so for 9, we need to find our radius, which is our diameter is 6 millimeters. So that means our radius is going to be half that, or 3. All right, I'm going to deal with this shape being A1 and this shape being A2. All right, for our formulas down below. All right, so A1, the formula for finding that is going to be 1/2 pi r squared, because that is the formula for area of a circle cut in half. All right, so we get 1/2 pi, and our radius is 3 squared. So 3 squared is going to be 9. So we get 9 over 2 pi, or 14.13. All right, so let's find our area of A2. All right, A2. That's going to be just that square, which is going to be base times height, or 2 times 2, or 4 millimeters squared. Sorry, I forgot to label that up here. All right, we're just going to add those two together. You get 14.13 plus 4. Make sure they're lined up properly. All right, put 2 zeros. We're going to add them up. We get 3, 1, 8, and 1. So we get 18.13 millimeters squared. All right, that is the area for this mushroom looking shape. All right, now let's find the area of this. It looks kind of like a basketball key. All right, so we're going to label this as A1. This is A2. All right, so first we need to find our radius. Our diameter is 6 going from here to here. So our radius is going to be half of that, or 3. All right, so we're going to find the area of A1. It is a square. So it's just going to be base times height, or 6 times 6. All right, so we get 36 meters squared. All right, now our shape of A2. The area of a half circle is going to be 1/2 pi r squared. So 1/2 pi, and our radius is 3, so 3 squared. All right, so we're still getting 9 halves pi. All right. Still going to be 14.13 meters squared. All right, now we're going to add them together. 36 plus 14.13. Two placeholders, we get 3, 1, bring the decimal down. 6 plus 4 is 10. The 1 we get 3 plus 1 is 4, 50.13 meters squared. All right, so that is the area for the shape for number 10. Make sure everyone can see everything. All right. Well, moving on to surface area. All right, surface area. All right, we have to identify the base first. This right here, identify the base first. All right, so we need to do that. The base for this one, all right, is going to be this up here and this down here, so it's going to be a rectangle. So this is our base. A rectangle. All right, it has 4 sides, obviously. All right, so now we need to figure out, this is a rectangular prism, right? So it's going to have 6 sides. All right, 6 faces. So we are going to have one face is 3 and 4. One face like that is 4 and 5. And then we have another one that is 5 and 3. All right. So our formula is just base times height. So we have 3 times 4. And that's a dot for multiply. And we have 2 of those. All right, because those are our 2 bases. So that's going to be 24 feet squared. All right, we have how many of the 5 by 4? We have one right here and then one right here on the back. All right, so 5 times 4. We're going to multiply that by 2 because we have 2 of them. It's going to be 40 feet squared. All right, and then we have this 3 by 5, all right, with this front piece right here in the back. And we have 2 of those as well. So 3 times 5 times 2. And that's going to be 30 feet squared. All right, so then all we do is just add them all up. All right, and we get 94 feet squared. So there's our area of our rectangular prism. All right, now let's find the area of the next one. So first we're going to have to identify the base. All right, now this is where it got some of us. All right, the base on this one is a triangle. These shapes are named for the shape of their base. So this base that's facing forward is actually the base, not this bottom rectangle, but this triangle. All right, so we have two triangles. Rectangular prisms have two bases. All right, and your base has three sides. All right, so we have got two of those, right? So we've got a right triangle with a height of 4 and a base of 3. All right, we've got a rectangle with a base of 7 and a height of 5. We've got another one with 7 and 3, and then another one with 7 and 4. All right. Now, the area of a triangle, remember, is 1/2 its base times the height, all right? So 1/2 base times height for our first one. All right, so we have 1/2 times 3 times 4, all right? But we have two of those, so we're multiplying it by 2. That's going to give us 12 centimeters squared. All right, that's for our bases, which are our triangles. All right, now we have one that is 5 by 7. See this front piece that's shaded that you can see? We have one that's 5 by 7, so 5 times 7. That's just a rectangle, so it's base times height. That's going to be 35 centimeters squared. All right, and then we have one on the bottom because this has a 3 and a 7, so we're just going to multiply 3 by 7 because it's base times height, and that's going to be 21 centimeters squared. And then we have one more on the back, which is 7, the length of this one, times 4. All right, so we get 4 times 7, all right, and that's going to be 28 centimeters squared. All right, those are all the areas of the shapes that are included in that triangular prism. All right, we add them up. We get 96 centimeters squared. All right. This one, we gotta remember, I'm gonna color in our base right here. That is our base, and this is our base. Okay. And then our first one, I'm gonna color in the base, I forgot to. That's our base, and this is our base. All right, so those is the area of a rectangular prism and then a triangular prism. All right. Now our problem number 3, we have to identify the base. Our base is a square. With 4 sides. All right, so this is, I'm going to color in our base. All right, so this is what we call a square pyramid. All right, we have a base with a square, so it's going to be, oops, that's more like a rectangle, sorry, but it's a square. 5 times 5. With a base of 5 and a height of 5. And then we have 4 triangles, all right? And they have a base of 5 and a height of 8. All right? So here's our area formula. Area is going to equal, we'll find the area of the base first, our square. It's going to be 5 times 5, and that's going to be 25 feet squared. Then we're going to find the area of our triangle, which is area is going to equal 1/2 base times height. So 1/2 5 times 8. And we happen to have 4 of those on a square pyramid. All right, so if we do that, our calculator is going to be 80 feet squared. All right, we're going to add 25 and 80 together. We're going to get 105 feet squared. All right, so there is our rectangular pyramid, which is more like a square, all right, because it's got 5 and 5. A square pyramid, a rectangular prism, and our triangular prism. All right, now let's do the area of a cylinder. All right, so we're going to identify our base. Our base in a cylinder is a circle. All right, circles do not have any sides. So this is our base. All right, and this is our base. All right, so we have a circle on top and the bottom with a radius of 3. All right, and then on the rest of it, we can cut a cylinder, because if we cut up a cylinder, it turns it into a rectangle. All right, so it has a height of 5. All right, and remember the length is going to be 2 pi times the radius, because that is our circumference. All right. So now our area is going to be, the area of a circle formula is pi r squared, so pi times our radius squared. It's going to be 9 pi. All right, and then we get 5 times 2 pi r, which our r being 3, and that's going to be 30 pi. All right, so if you add those two together, we get 39 pi, or 122.46 meters squared. Make sure we have all our area being meters squared. You can pause right there since I had it over a little bit so you can get all the answers written down if you didn't see them. All right, we're going to move on to volume. All right, so for this one, we're going to find the volume of each shape, and then we're going to identify if the shape is a prism or a pyramid. All right, we can tell whether a shape is a prism or a pyramid. A prism has 2 bases, and a pyramid only has 1. All right, so all we have to do is identify whether this shape is a prism or a pyramid for number 5. All right, so I'm going to color in bases. All right, so I colored in 2. So that means that we have a prism. All right. So the volume is going to be the area of the base, which is a capital B, times the height. All right, so the area of the base is 3 times 4, base times height, times the height of our prism. It's going to be 5 times 5. All right, if we multiply all that together, our volume is going to be 60 feet cubed. So remember in volume that we are dealing with cubed because we are multiplying 3 numbers together. So we're literally multiplying the word feet 3 times. So we can change that to a cubed. All right, so this is a rectangular prism. All right. Number 6. All right. We have, remember their prisms and pyramids are named for the base of what they are. This one is still going to be, the base is going to be this triangle and this triangle back here. All right. Sorry, that's not colored in, right? Marker's kind of running out. All right. So it is named, it is a prism because it has 2 bases. All right. So the volume is going to be the area of the base, which is capital B, times the height of the prism, all right? So our base, all right, area is going to be a triangle. A base is going to be a triangle in this instance. So it's going to be, our area is 1/2 base times the height. So 3 times 4. All right, so that's going to be 6. All right, so we have 6. All right, now we're going to put it back up here. Draw a box around that. We're going to put it back up here. 6 times the height of our is going to be 7. All right, so 6 times 7 is 42 centimeters cubed. All right, so this might be a little tricky to find the height, all right? So it's going to be this number right here. All right, because this is the base, we have to think about, like, it's going to look like a cake slice, kind of. And so the height, if you have to think about it, the base needs to be, the green part needs to be flipped over. So the green is on the bottom. So if you flip it over, that 7 is going up. All right. So number 7 here, we're going to identify our shape here. Our base is going to be down here. This is going to be a pyramid because it only has 1 base. All right. And I forgot to say up here is a triangular prism. All right, and down here, this is going to be a rectangular pyramid. All right, so the volume, all right, is going to be 1/3 times the area of the base times the height. All right, don't worry on remembering all these formulas. I will be giving you a sheet for the test that has it all on there. All right, so we get our base is kind of a square rectangle. So it's just base times height. So it's 5 times 5, or 25. All right. So when we fill this in, we get 1/3. Area of our base is 5 times 5 times our height. Our height is going to be from here to here, 6. All right, so we get 1/3 times 25 times 6. And you put that in your calculator and you get 50 meters cubed. All right, moving on. We're going to identify our base here. This is a triangle as our base, so that means we have just 1 base. That means we're going to have a pyramid. So this is going to be a triangular pyramid. All right, so the volume is going to be still the same as the rectangular pyramid. So it's going to be volume equals 1/3 times the area of the base times the height. All right, so our base in this one is a triangle instead of a square. So our base area formula is going to be 1/2 base times the height. So 1/2. So times 3 is our base. So it's 3 times 1, our height. All right, so we get 3 over, sorry, I wrote 2. That's supposed to be a 3 or a 2. 3 over 2. All right. Now we're going to do 1/3 up here. Our base area we already found was 3/2, and our height is 4. All right, so we get, and we can figure this out. We can do, I can take a 2, right, and put that, all right, and the 3's can go away because they're just 1 divided by 1. So we're just left with that 2 that's over there. So it's going to equal 2 feet cubed. All right, of course you could plug all those fractions into your calculator. All right, and multiply them and it'd still come out as 2 feet cubed. Do not forget your cube for volume. All right, now we are on to angle measures. This is the last page in our study guide. It's one of the last things that we worked on. All right, so when we're finding the measure of x, and we're going to name the triangle. All right, so remember that a triangle has to add up to 180 degrees. All right, so we can set all of these equal to 180. So we have 180 equals, and then we can put x, because that's the one we're missing. All right, plus we're going to add this 2x minus 5. All right, and then we're going to add 62 as well, because all of those angles have to add up to 180. Let's combine our like terms here. We've got an x and a 2x. So now we have 3x. All right, now and then we have also 2 numbers here. We got minus 5 and 62. All right, so 62 minus 5 is going to be 57. That's going to equal 180. All right, so we end up with 3x plus 57 equals 180. All right, so first off, we've got a 2-step equation. We're going to subtract 57 on both sides. All right, we're going to be 180 minus 57. That's going to be 123 equals 3x. All right, we divide by 3 on both sides. We're going to get x as equaling 41 degrees. All right, so x equals 41 degrees. If we put in 41 for x at this one, 2 times 41 minus 5, we'll get 77 degrees, all right? So that means we have a 77 degree angle, a 62 degree angle, and a 41 degree angle. All right, so that means we have an acute, because none of them are above 90 degrees. All right, and we have a scalene triangle because none of the sides are the same size. All right, so we have an acute scalene triangle with an angle x equaling 41 degrees. All right, please do not forget to put your degree sign. All right, so we've found the measure of x and we named the triangle. So all of this needs to be included to be correct on your test. All right, now we're going to go on to number 2. We've got 34.6 degrees, 118 degrees, and x. All right, so like the last one, we have to set them equal to 180 degrees. We have 180, move this over so we can see, equals 34.6 degrees plus 118 degrees plus x. All right, we get 180 equals, if we add 34.6 plus 118, we get 152.6 plus x. All right, to solve for x, all right, we're going to subtract 152.6 on both sides. All right, we're going to get x is equaling 27.4 degrees. All right, so this is going to be 27.4 degrees. So we have a triangle with a 34.6, 27.4, and 118 degrees. All right, so since one of our angles is above 90, that means we have an obtuse. All right, and none of the sides are the same. So it's going to be a scalene again. All right. Now we're going to find the angle measures and describe their relationships. All right. Angle 1 is 95 degrees. All right, so first we're going to put 95 degrees right here. All right, so we have angle 1 and angle 3. All right, angle 1 and angle 3, they are going to be vertical. All right, they are vertical. All right, angle 1 and angle 2, all right, they are going to be supplementary. Why are they supplementary? They are on a line. You see they share this line right here, which means they are equal to 180. Supplementary, I'm just going to write sup. And they are also right next to each other. They're neighbors, so that means they are adjacent. Adjacent. All right. So that's how we can label the relationships. Now we're going to figure out what the size of the angles are. All right. So when we have the rules with angles, all right, we have vertical angles. Our vertical angles are going to be identical. So that means angle 3 is also 95 degrees. All right. And when we have a supplementary angle, it's going to equal 180. So that means we can set 95 plus angle 2 equal to 180. All right, we subtract 95 on both sides. Means angle 2 is going to equal 180 minus 95, or 85 degrees. All right, so 85 degrees. All right, so if angle 2 equals 85 degrees, angle 4 is also going to be 85 degrees because it is vertical. All right, so angle 2 and angle 4 are vertical as well. All right. Angle 4 and 3 are also supplementary and adjacent. Likewise, angle 1 and 4 are supplementary and adjacent, and angle 2 and 3 are supplementary and adjacent. All right. Now let's look at number 4 over here. They have given us that this angle right here is 45 degrees. All right. So we see this box right here. That means those two angles are 90 degrees. That means they are complementary. That means they equal 90. All right. So angle B and 45 degrees, they're next to each other. They're neighbors, so they are adjacent. And they are complementary. All right, because they add up to 90. So that means 90 minus 45, oops, that's a 45, sorry about that, is going to equal angle B. So that means 90 minus 45, which is half, is going to be, angle B is going to be 45 as well. All right. All right, so this whole line right here is going to equal 180. So that means all angle A, angle B, the 45-degree angle, and the 63 angle all have to equal 180 degrees. All right, so we have 180 going to equal 63 plus 90, because these two angles add up to 90, plus angle A. All right, so 63 plus 90 is 153 plus angle A. That's going to equal 180. All right, we subtract 153 on both sides. That means angle A is going to be 27 degrees. All right, means angle A is 27 degrees if we label it. All right, now we're going to find the value of x. All right, so we have a quadrilateral. It is a four-sided shape. All right, 1, 2, 3, 4. All right, quadrilaterals, if we remember, have to add up to 360 degrees. All right, so 360 degrees. That's how we're going to solve and figure out what x is. We know this angle is 130, this is 75, and they were telling us that this angle right here, because of this square, is 90 degrees. So if we add all those up, we should get our angle x. All right, and subtract from 360, we'll get our angle x. All right, so 130 plus 75 plus 90 plus x. All right, that's going to equal 360. So we add all those up on our calculator. We'll get 295 plus x is going to equal 360. All right, we subtract 295 on both sides to solve for x. Let's cancel out. We're left with x is going to equal 65 degrees. All right, so that means this angle right here is 65 degrees. Now, if you added those up to check your answers, you'd add 65 plus 130 plus 75 plus 90, and that should give you 360. If it doesn't give you 360, then you know something went wrong. I'm going to try it again. All right, last problem. We have got to find that value of x. All right, so we have got a supplementary angle right here and adjacent. All right, they're right next to each other, but they are supplementary because it's on this 180 degree line. So we're going to write sup. It's going to be 180 degrees. All right. So we could set, that means we could set both of those equal to 180 if we add them together. So we get 180 is going to equal 2x plus 3x plus 10. All right, that solves for both of them. All right, let's combine our like terms. We got 5x because 2x and 3x, we add them together, we get 5x plus 10 is going to equal 180. All right, now we have a two-step problem. We're going to subtract by 10 on both sides. We get 170 is going to equal 5x because those cancel out. All right, we divide by 5. All right, those cancel out. We're left with x is going to equal 34 degrees. All right, so if x equals 34 degrees, we fill it in. 34 times 2, that's going to give us 68 degrees. We put 34 in for this one. 3 times 34 plus 10 is going to be 112. All right, and then you check to make sure they both equal 180, and then you'll know if you're correct. All right, that's all for the study guide. You guys are going to do amazing on this test. I know it. Just remember, I'm going to give you a formula sheet with all the formulas, so you don't have to memorize all that part. Just got to remember how to do things. All right, you're going to do awesome, and I'm very proud of you.